Hello everyone. Thank you so much for joining me today. And I'm just tuning. Okay, so today I'm going to share with you how to kind of like use um, Unity, Sentis AI, how to import Onyx from the existing AI model, the Hugging Face. So yeah, let's start. Just have to. Mm, record. Okay, first, thank you so much for tuning today and support us on Patreon to access the code and also access the um, um, kind of like a different perk and also different assets. Yeah, and also join the Zoom with me. And also recently I just released the book. So yeah, so if you are interested in learning about spatial design, feel free to just chain in. And also today I am going to teach you how to um, kind of like do uh, kind of import the Onyx from the pre-trained model and import into Python and then export to Onyx and then kind of like get into Unity. So let's see today's model. Yeah. Okay, if you can see this one, okay, what I will do is maybe for some reason there's an echo, right? Okay. Okay, so feel free to leave any message if you have any thoughts, comments. Or right now we have 21 people to watch. So if you find out the audio was not great, let me know because I have two computer screens and sometimes I might not be able to take care of everything. So yeah, I have my phone here. So if you have anything, let me know. Post the comments. You can say hi, where you are from and what you are looking for or what you want to learn. Feel free to leave the message. And Armin today is joining us. So if you have any questions, feel free to just jump in and unmute yourself. Yeah, so just let me know. Okay, so right now, let me share with you what I'm going to share with you today. So it's already the final one. And we only have 1 hour, so I will very quickly run through. Um, so pretty much later on, I will share with you how to um, um, kind of create a PyTorch file and then import the LXNet object detection types of model in and export from PyTorch and become this Onyx file and import inside Unity and also import Unity Sentis and then write a script, right? And then, for example, uh, for this model, we have trained 1,000 images. So if you see labels, yeah, later on when it is run, you can see 1,000 images or 1,000 labels. And then results, you can see each label or each kind of category or class. It has the probabilities of each one. So for example, like one of it is golf, right? So if you go here and you can see labels, the first one is American Cold Buster. So you can see like those are 1,000, you see labels, there are 1,000 labels already being trained and result. each element has its own probabilities. So at the end, it will kind of show the highest one and give you the answer golfing ball. Okay, so you can definitely apply these types of AI model or the skills into anything you want to do. For example, you can later on put output visualize in the world space, and you can do some interesting selection, AI training, some game mechanics. Okay, cool. So let me share with you start from how to import the LXNet, this image data set into PyTorch. Okay, so let's start from here. Learn. Okay, so I want to share with you a little bit of like how this being trained, and all the link and resource will be our Patreon. So make sure subscribe if you are interested in getting all the access and source code. Okay, so let me share with you. Where's my cheat sheet? Okay, give me a sec. Okay, so today we can go to this URL. It's called Learn OpenCV, and it will teach you how to use pre-trained models for image classification. So we will learn how to do this in PyTorch. So at the beginning, I want to share with you what's the image classification. So we will later on get the pre-trained model. It's called LXNet. It has a huge data set, and we want to use this pre-trained model called LXNet. If you want to see how it is involved, one of the kind of like exporting example is ResNet. But today we are going to use the one that we are going to use is called LXNet. Okay, so pre-trained models are neural network models trained on large database like a ImageNet. So if you see this, LXNet is a pretty well-trained ImageNet data set. If you want to know more, pretty much it was kind of like a pretty the way it trained is that you import tons of images and you start doing the training. If you want to know what's the training part, there is another site called um, um, Vox, Voxel 51. So this one is helping you to understand how all those like image train. This is kind of like a software help you to kind of like label things, classify things, and later on kind of make it a nice data set. Yeah, if you see this, you can see, maybe I can enlarge it. Let me see if I can enlarge it or not. Okay, great. So you can see better. Okay, so for this one, 51, just call it 51. So if you see this one, you can definitely download the entire file and open it on your own. Pretty much you can import a lot of different images, and you can start kind of doing the box and tell the model what's that. The more data your model has, the better. So if you see this, for example, like, oh, I want to train all the vehicles. So the way to train it is that you import all the image, and the image needs to be the same size. And then you start kind of like putting boxes, and then start putting labels, and start telling what to do. And later on, you can see all the validation, or like you can start seeing all the stuff. So I think this is a very good software helping you to classify and labeling things. So yeah, so if you are interested, feel free to download this model and train or import your image or import your data and start training and putting labels in. So this one is a good one. Okay, the other one is that's kind of like a star, like following what's going on with this one. So if you see this, right? So what I will do is I will put this, I don't know how well it go because there are some instructions, but maybe I can start with the instructions and then later on I can jump into the code. So maybe that might be a little bit easier. Okay, so first you need to install Torch Vision using PIMP. So you can use your terminal from VS Code or command line or terminal. Yeah, so you can kind of like first you need to install Torch Vision, and later on you need to create a Python um, file on your VS Code. Yeah, I usually do a folder, and that folder is called Python or PyTorch. And then I put all the AI file in. So you can also do that. So from so you copy and paste this one. Pretty much in this one, this code is we will import the models. And those are the data set from those are the kind of like the image set, and we will do the AlexNet. Okay, so if you scroll down, this is how AlexNet being trained, which so those, if you see there are like boxes, right? Those are the weights, convolute. So those are kind of the magic kind of like an array of numbers that allows you to put the image in, and then they will do the prediction. And those are involving a lot of math. So it just show you how this model being trained. Okay, so just get back and see. Anybody has any questions, feel free to just chain in. 27 people read it. Okay, so yeah, thanks for training. Okay, so this is the AlexNet, and if you want to understand the AlexNet, go here. Yeah, so so pretty much you need to resize it to 256, and you need to use center crop. After you resize it and center crop to 224, 224. So this has a very specific way you need to treat the image. If you kind of resize it, or if you do the different size of the image, it won't even detect it. So make sure your image size is the those size, and do the center crop for 224, and later on you need to do the normalize. So there are a couple of ways. If you go back to see this one, so first use terminal to install your Torch Vision, and then create a Python file, import your model. Okay, then we will use AlexNet. And this is how AlexNet kind of created. And then we need to start loading the pre-trained model. So we need to copy and paste this code. Later on, I will show you the entire final code. AlexNet model.alexnet, and this is pre-trained equals true, which means we just want the result. We don't want to train the model. So you can do training the model, or you can just use the final result. In this case, we are going to kind of like use the pre-trained model, and so pre-trained pre-trained equals true. So in order to know whether this file is being uploaded or being downloaded, we can print it first. Yeah, so, and you will see in terminal or you will see in the console whether this model being imported. Okay, step 2, specify image transformation. So this part is very important. This part pretty much is starting to resize all the images to 256 and do the center crop. Without this part, you couldn't even fit the funnel of the entire training session. So this is the very important part, and you will get a lot of errors. So first, we need to start import, and we resize the image that we import, and we do the center crop to 224, and later on we need to normalize it. Without normalize it, it couldn't really tell, do the image recognition. So those 3 are the essential part for this AI model to do the magic. So if you see this, yeah, we need to get the transform of the images or image. Today we just showed one image, static image, and resize the image into. So this code, this explanation is just explain this code. So for example, resize the image to 256 by 256 pixels, which is this one, transform resize 256, and crop the image to 224 by 224, this one. So resize first, center crop set second, and normalize. Yeah, convert PyTorch tensor data type. So it will be an array of numbers. So those, if you see those, it's a data set. It's pretty much array of numbers. So, and it has width, height, and depth. Imagine it's a set, tons of numbers, and it has the width, height of array, and the depth of array. So those are all numbers. It used mathematics to train it. Okay, so this one. And yeah, finally, we need to normalize the image so we can get specific values at the end. Step 3, we need to load the input image and pre-process it. So if you see this one, we can use Pillow, PIL, and yeah, you probably need to install Pillow. So PIL. And then once we do this, we can import or open our image. And this image dog.jpg need to be inside the exact folder of your file folder. So you drag this dog, you drag this dog into it. And then next, pre-process the image and prepare a batch to be passed through the network. So we just, yeah, kind of prepare it. And then we are going to input the model, right? And then we input this model, and we kind of just, we want to see what's the output. And once we just think that AlexNet is a black box that has all the weights of the AI, and once you import or insert an image, it will start kind of doing the validation, and it will share or show you the final result according to the label or classification. So the weight or the output. So for this model, it has 1,000 labels for it, for I would say dogs. So you can pretty much get different dogs or animals or some other objects. You can kind of put in and see what's the probability is and what types of labels or class that this model will associate, or the result, or will understand what types of label will be what will get the highest probability. And yeah, so you can see we still haven't got the images class or label. For this, we will first read and store the labels from the text file, a list of 1,000 labels. Okay, so if you're interested in what's that label about, let me share with you this one. Once we import the AlexNet, you will see this is the labels. The labels means that they import 1,000 images or, a lot of images. And later on, they come up with all those names that the AI can understand those names. So yeah, so those labels. So you can see the AlexNet can understand, for example, firebolt or fire engine or fire screen. So if you have any images associated with all those kind of labels, it will show at the end, it will trend and pick the highest probabilities and show the final one for you. So this is, or you have to code or you have to make it show up, but it pretty much do using all those like 1,000 kind of labels or names for to identify it. Okay, so need to open this kind of like a ImageNet classes text. So this is the one that you want to open it. Okay, so we kind of want to make the probability, the highest is 100. So for example, like if the number is very high, it will close to 100. If the number is not too high, it will be kind of close to 0. So that's kind of the way it is. And then you can see like if you import a series of, I would say, the pictures, you can see the label, it kind of detect. And this will be the number it will see. So you can pretty much drag and drop all these images and just to try it out. Yeah. Okay, so this is the description, and now we jump into the real code. Okay, so first, what you need to do is to create a Python file that is called object-detect.python. So what you do is pretty much before we mention, you need to import or install your pimp, right? Install pimp install torch vision. So if you want to see, let me kind of share this screen. So what you need to do is copy and paste this code to this one. I've already installed it, but you need to first to install this torch vision if you don't have it. And second, what you need to do is you need to import the model, right? So you import the model, and then yeah, and then you get into AlexNet, and then you copy and paste this code, AlexNet equals models.alexnet pre-train true. So this is the code that will allow you to kind of get the model, and we want the pre-train one. Pretty much copy and paste from this one. So this one is very important. You need to copy and paste to your PyTorch file. our Python file. So yeah, so you copy and paste it, and you can do the resize first, and then center crop for second, and then normalize it, just to make sure the it will understand, AlexNet will understand how what's the data looks like, or doing the better prediction. Okay, so later on we will import pillow, so we can import image. So import pillow. And then image, we will open the dog JPG. So you can pretty much drag this dog JPG to your folder. The folder that you create this Python file. So you drag and drop inside and call this file's name is dog.jpg. So here you are calling, yeah, I mean, I create, or I drag and drop the goldfish. So you can find goldfish or in any other JPEG you find online. You can do dog JPG, it's all good. Yeah, maybe we can try dog JPG. Of the OG, yeah. Okay, so we need to kind of start preparing it and start putting inside, and with all the classification text that we want to import inside all the data set. So later on, it will show what's the name of this image, and what's the probability of it. So let's just open it. Yeah, so yeah, you can see semoid, and the probability is high. Yeah, so the dog is semoid, but I think I changed this one to doggy. So you can put a couple of the files. Let me share with you what I have actually inside. So I have doggy, I have goldfish. I can later on maybe try, oh yeah, dog is this one. So you can put, insert different types of images and use kind of like a try it and run it and see if you can see the final result. Yeah, but you probably need to import matplotlib for all the data or the numbers to show up on your image. Okay, so yeah, so you can see doggy. Let's try doggy. Doggy is the one that you can see on the, okay, so Labrador retriever. So yeah, so this one, it recognizes is Labrador retriever. Okay, so this is how the entire import the language model, and also how it resize and normalize it. And you import the JPEG file, and then it will output and according to all the label name, and show all the probabilities. And the maximum probability is 100. If the number is closer to 100, it means it's very sure about it. Okay, so after this, we need to export the Onyx, right? So what we need to do is pretty much it's the same thing here. And what we need to do is we want to export this AlexNet pre-trained as an Onyx file. So if you want to see this, there's another URL you can get. You need to create another Python file just to name export Onyx, and then you can click it. And once you click run, and you will generate an Onyx icon into the folder, which means that you will get an Onyx file, which is the brain of your model, AlexNet. Okay. So export Onyx. So if you click this, okay, so what I will share with you is, give me a sec. Okay, this one. Okay, so there's a website called How to Convert a Model to Onyx in 5 minutes. So you can see you import PyTorch and you import a model, and it uses ResNet 50. But what we do is we replace ResNet 50 to LXNet. So for example, you load this model, and then you copy and paste the entire code here. So yeah, all we need is the top and then button, which is we wanna do Torch Onyx export. So yeah, so you can export the Onyx file. Okay, so if you run this, later on it will generate LXNet and it's an Onyx file. So yeah, so you pretty much follow the steps and copy and paste, and you can get it. But remember, after you copy and paste from the website, you need to change the original kind of like the model to LXNet, because this one is what we want to do. Okay, so what our goal for this demo is to export an Onyx from the PyTorch file or Python file. And then we go to Unity. Okay, finally. Okay, so first for Unity, we wanna kind of do the Sentis install. I share the how to install it in my previous video, but just for a quick recap, all you need to do is, okay, I just tried it this morning, but I can share with you again. So you go to Package Manager. First, you need to go here and click Preference up. Project settings. And you need to make sure enable pre-release packages is checked, so we can use the Sentis AI. Go to plus button, package manager, plus button, install package by name. Okay, so all you need to do is, because I think this one is hidden very deep, so you need to type com.unity Sentis, and then Sentis. Okay, you click install. Okay, so this will pop up. I've already installed it, but you can take a look of the description. You can use either GPU or CPU. Normally we use GPU, and you can see what version you are using it. And it comes with a lot of examples. For example, you can add your custom layers. If you are very good at the large language model or AI model building, you can definitely add your custom model layers, or you can convert tensor to textures or convert texture to tensors. There are tons of it. You can, or run a model a layer at a time. Like there are different ways to do all those things. So you can definitely do things through or import some samples and try it out. Okay, so what you will do is open this one. Okay, object detection. Object detection, yes. Okay, so okay, so if you want to learn how to import Onyx into Unity, you can take a look of Unity Sentis documentation. It has some basic types of descriptions, and you can copy and paste and try things out. basically what you need to do is to import unity.sentence. All those other things is if you want to do some operations, you can pretty much do it. Okay, so you can import the texture 2D. So later on, we will do some images. So this will be golf ball JPG. JPG. So yeah, so later on we will import whatever texture we have and input texture crop. I find online there was kind of the code which is using C# code or using Unity to center crop of a texture. I copy and paste. You can see the code. Yeah, later. So and you can see the model asset, right? So later on, we just export the lxnet.onyx. So we're going to import this. Okay, so I mean, any other questions? I know I talk a lot. Just wanna check. If you have any questions, feel free to just leave on the chat. Okay. Anybody has any questions, feel free to leave on the chat. And I will try to just take a look. Okay, Peter say good morning. Sounds good. Okay, thanks. Okay, so yeah, we will do runtime model and iWorker. iWorker is the interface to execute the models because all the AI models, scientists create another workplace for AI model to run besides its current Unity update. So you need to create another space for this to run. And you need to get the labels and results. You can have an array, but right now we just have one. We just have one image, so it's just one. Okay. Yeah. Okay, this one will be at the end, what types of answers it will predict. So you can see we, all those will be, if you go to Sentis, let me see, Sentis.ai. Let's see. I have Sentis.ai share. Yeah. Unity Sentis UI documentation. Okay, so pretty much you can take a look of this. Oh. Okay, so you can see this Sentis overview. So if you wanna get started, you can see Sentis flow. First, you need to use Unity Sentis as your name, right? So you do this, and later on you need to put your model assets, load this model, and then you need to import the name of your file as texture 2D if you want to do texture 2D, and you will make it input texture. You need to create an iWorker, which it allows you to kind of run this model, and later on you need to execute. And yeah, so you can take a look of kind of like this code, how this works. This is the kind of like one of the previous demos we create. You can dive into the old video. Pretty much you have a public space for for the user to insert what texture 2D they are going to input. And also you input a model, and later on you create a iWorker runtime model, and at the end you want a result, right? So, and at the end you kind of want to dispose the thing just because it is, give me a sec. You want to dispose this entire model because you don't want it to keep running, and it will grow more and more, and it will eat your memory. Okay, cool. So this is kind of like how it goes, and you can see the simple scripts. So yeah, import mod. So yeah, you can kind of dive into all the details of how this works. Yeah. Yeah, so, okay, so this one is the most important thing, Unity sentence, and then put the texture 2D, and you need to crop it, and you need to import the LXNet that we just export from PyTorch. Yeah, like using the code. Okay, so we create a runtime model, and we create a worker, and we have labels, which is the text file I just showed a few minutes ago. This text file, which has 1,000 types of trained objects. Okay, we will get into that. So yeah, so labels, result, we want to know what's the result. And this result will have, an array of all the 1,000 objects, and with the probabilities next to it. And answer will be what's the only one being picked with the highest probability. Okay, so first we need to get the data paths, and we need to kind of like get we want to load all the lines. So we want to load all the 1,000 kind of labels. We run this model, and we start cropping this, right? We want to crop this, and this is called resample and crop. This code I find online. Okay, so this one, if you kind of type or Google search how to crop, center crop an image in Unity or using C#, you can find this code in one of the forums. So pretty much you import the 2D texture, and you have the target width and target target height. Then it will export or return a texture 2D. So you can kind of take a look of this one. I pretty much copy and paste, so you can just see how the math working to really force it to crop. Because in Python or PyTorch, you can just use a couple of lines to do it. But for Unity, you probably need to have more code to force it to crop. Okay, so you import it, you crop it, and then you create a runtime model using your GPU compute, and then you execute the import tensor. So your input tensor, right? So you input this, and input this is from the input texture, right? And this input texture, at the end, we want to kind of make it 224 by 224. At the end, we will output. Yeah, this is just like the sentence way of output the result, right? So you can pretty much follow, copy and paste, and play around Unity documentation. Yeah, so at the end, you will see the result, and result.max, and it will show the answer will be the index of max. So which means that whatever gets the highest probability, it will show that the name of it. And at the end, we want to dispose it so it won't keep running it. Yeah, so this is just the code. This is the cropping code that I copy and paste from online. Okay, so we create a manager, an empty object, and we will put the code in. Okay, we put the code in, right? So you can kind of like get into this, for example, like input texture, you can just grab in, and model assets, you can just get from the folder that we generate from the PyTorch file. And then if you run it, so the goal is to detect this input called golf ball, right? And then it will run. So this texture will run through this AlexNet model and all the labels. And the AlexNet will start running through all those different types of elements, right? And all the label elements, it has resolved. For example, it has some numbers. So for example, -1, 115, and yeah, so if you see this, so element 1 equals element, yeah, oh, element 0 equals the label. So tinge, if you are looking for tinge's probability, this image's probability of a tinge is -0.27, something like that. And it's like 1,000. So those two can be combined. And the answer is, you can see golf ball got the highest result probabilities. And the golf ball is in one of the, if you see this golf ball. Yeah, it's in one of the labels by the pre-trained model AlexNet. One of it is golf ball. And golf ball got the highest probability. So the answer export the golf ball. Okay, thank you so much. Any questions? Taking. Anybody has any questions? Armin, do you have any questions?
Yes, can you run it again, please?
Oh, okay. Yeah, golf ball. You can see those like probability. This one is kind of a perfect one. I can share with you the failure one. Yeah. It's kind of like it's trying to understand the thing, but I think for Unity, when you crop and normalize things, it's probably not crop and normalize the way that the PyTorch, the original platform does. So for example, this is like the answer is hilarious. So for example, if I input another texture, I'm trying to run this model, it comes out to fire engine. Yeah, so it's, yeah, of course it's red and it's kind of gimmicky, but I would say even though you are trying to crop it or normalize it, sometimes there might be some off. Probably need to redo the cropping or anything, but I would say golfing ball is the most close training. For example, if you put this one, yeah, let's run it. It's just like a lot of really unexpected. Okay, Angora. Okay, so if you go to Angora, what's Angora is this one. Angora is actually a rabbit. Yeah, so it predicts something more like a kind of similar but not exact. So I would say for this types of things, yeah, go ahead.
Sorry, so question is, so all we did here was bring in the model into Unity and run the images against the model in Unity, right?
Yes,
instead of
yes.
outside.
Yes,
Okay.
and we need to bring the sentence in. Do you know how to bring sentence in? You need to
The
kind
package
of,
manager. Okay.
yeah, you need to kind of install package by name. You need to com.unity.centis and install.
Right.
You couldn't
But
find
that's not the
anywhere.
point. The point is
Yeah.
I can bring in any model
Yes.
into
Yes.
Unity. It's not the image processing, but any
Yes.
model.
But you need to import the Onyx one. Yeah. Currently, they kind of do the Onyx. For example, if you have a Hugging Face, you need to kind of get the pre-trained model and import the Onyx in. Export to Onyx and import Onyx in.
Understood. Okay. Right. So it doesn't have, okay. So if it's not from Hugging Face or from somewhere else, then is the process the same? Still have to go through Onyx?
I think so far they are, if you go to the Unity, right, package, right, get start import a model, right? So right now it seems like there's like a, you need to
Onyx
get the
only, okay.
Onyx. Yeah, it seems like Onyx only.
So it doesn't
And
matter if
yeah,
it's coming from Hugging Face or anywhere else.
yeah,
We can, if we can change it to an Onyx model, we can
yes,
import it into
yes,
Unity.
yes, yes.
Okay.
So pretty much Onyx, and it has some like a coding, like for example, like getting started, simple scripts. So you can kind of like just take a look, and they have like a forums, so you can pretty much yeah, take a
Can
look
we
on
bring a
forum.
chatbot into Unix?
I think
Sorry.
so. Yes, yes. As long as, for example, like a Hugging Face. Right now, I'm trying to get some different Hugging Face models into Unity. So last time we bring like a diffusion, stable diffusion in, right? And definitely we can put, oh, this is cool. So we can put like some different,
Meta. Okay.
yeah, yeah. So for example, like just all those, as long as you can export to Onyx, and you probably need to write some code for everything to make sense. So yeah, text to speech, text to audio, all those like as long as you can make the kind of like the Onyx export to it, you can import using Sentis AI to do it.
That's interesting. Okay.
Yeah, cool. Yeah, and actually we will have a speaker event right after this. So yeah, in 4 minutes. So yeah, thank you so much, everybody, and I will see you next week. Bye bye.
Thank you.
Yeah, thank you.